Searching for exoplanets and habitable zones, a quest for life beyond Earth. Imagine staring up at the night sky and knowing with absolute certainty that somewhere out there another Earth exists. A planet teeming with life, just waiting to be discovered. That's the promise of exoplanet research, and it's a promise we're closer than ever to fulfilling. The search for planets beyond our solar system, known as exoplanets, has exploded in recent years. What was once science fiction is now a rapidly advancing field of scientific inquiry. We're not just finding planets, we're characterizing them, analyzing their atmospheres, and searching for signs of life. This incredible progress is driven by advancements in technology and data analysis. Powerful telescopes, both on Earth and in space, are constantly scanning the cosmos. Sophisticated algorithms are sifting through massive data sets, revealing hidden worlds we never knew existed. A key focus of this research is on exoplanets located within the habitable zone 8Z of their stars. These are the planets that hold the greatest potential for harboring life as we know it. The discovery of these worlds is a crucial step in answering one of humanity's oldest and most profound questions. Are we alone? The habitable zone, often called the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist on a planet's surface. It's not too hot, not too cold, but just right. This zone is defined by the range of orbital distances where a planet could maintain liquid water. Liquid water is considered a crucial ingredient for life as we know it. It acts as a solvent, facilitating the chemical reactions necessary for biological processes. Therefore, finding planets within the HZ is a primary focus in the search for extraterrestrial life. However, it's important to remember that the HZ is just one piece of the puzzle. A planet's location within the HZ doesn't guarantee habitability. Other factors, such as atmospheric composition and geological activity, also play a significant role. The size and location of the habitable zone are determined by several factors, primarily the star's luminosity. A brighter, more luminous star will have a larger and more distant HZ. A dimmer star will have a smaller and closer HZ. A planet's size also plays a role. Larger planets are more likely to retain an atmosphere, which can help regulate temperature and protect the surface from harmful radiation. Smaller planets may struggle to hold on to an atmosphere, making them less likely to be habitable. Atmospheric composition is another critical factor. The presence of greenhouse gases, such as carbon dioxide and methane, can trap heat and warm a planet's surface. The absence of these gases can lead to a frozen, uninhabitable world. While liquid water is essential, it's not the only requirement for habitability. A planet needs a stable and protective environment to support life. This includes factors like atmospheric density, a magnetic field, and geological activity. Atmospheric density is crucial for regulating temperature and protecting the surface from harmful radiation. A thick atmosphere can trap heat and shield the surface from ultraviolet radiation and cosmic rays. A thin atmosphere offers little protection and can lead to extreme temperature fluctuations. A magnetic field is also important for shielding a planet from stellar winds, streams of charged particles emitted by stars. These winds can strip away a planet's atmosphere over time, making it uninhabitable. Earth's magnetic field protects us from this harmful radiation. Geological activity, such as volcanism and plate tectonics, can also play a role in habitability. Volcanism can release gases into the atmosphere, helping to regulate temperature. Plate tectonics can recycle nutrients and maintain a stable climate over long periods. Scientists use a variety of methods to detect exoplanets. Each method has its strengths and weaknesses, and they often complement each other in the search for new worlds. The most common methods are the transit method, the radial velocity method, and direct imaging. The transit method is used by missions like Kepler and TESS. It involves observing the dimming of a star's light as a planet passes in front of it. This dimming is very slight, but it can be detected by sensitive telescopes. The transit method is most effective for planets that are close to their stars and have large sizes. The closer a planet is to its star, the more frequently it will transit. The larger a planet is, the more light it will block, making the transit easier to detect. This method has been incredibly successful, discovering thousands of exoplanets. It also provides information about the planet's size and orbital period. The radial velocity method, also known as the wobble method, detects the gravitational tug of a planet on its star. This tug causes the star to wobble slightly as the planet orbits it. This wobble can be detected by measuring the changes in the star's light spectrum. This method is sensitive to larger planets, especially those orbiting closer to their stars. The more massive a planet is, the stronger its gravitational pull on the star. The closer a planet is to its star, the faster it orbits, and the more pronounced the wobble will be. The radial velocity method is also sensitive to planets orbiting further from their stars. While the wobble may be smaller, it can still be detected over long periods. This method provides information about the planet's mass and orbital period. Direct imaging involves directly observing the reflected light from an exoplanet. This is a very challenging technique because planets are much fainter than their stars. The glare from the star makes it difficult to see the planet. Direct imaging is most effective for large young planets that are far from their stars. Young planets are often hotter and brighter, making them easier to see. Planets that are far from their stars are less obscured by the star's glare. This method allows scientists to study the planet's atmosphere and surface properties directly. It can also be used to search for signs of life, such as the presence of certain gases in the atmosphere. Once an exoplanet is discovered, scientists can analyze its atmosphere using spectroscopy. This involves analyzing the light that passes through the atmosphere as the planet transits its star. Different molecules absorb light at different wavelengths, creating a unique spectral fingerprint. By analyzing this fingerprint, scientists can identify the molecules present in the atmosphere. This can include water, oxygen, methane, and other gases. The presence of these gases can provide clues about the planet's potential for habitability. The detection of certain molecules, such as oxygen and methane, could be indicators of potential biological activity. These gases are produced by living organisms on Earth, and their presence on another planet could suggest the existence of life. The discovery of a planet in the habitable zone is just the first step. It doesn't guarantee the presence of life. Many other factors, such as atmospheric composition, geological activity, and the presence of liquid water, must also be considered. Despite these challenges, the future of exoplanet research is bright. Continued development of advanced telescopes, both on Earth and in space, promises to reveal even more about planetary systems. These telescopes will be more powerful and sensitive, allowing us to detect smaller and fainter planets. Continued development of analytical techniques will also be crucial. We need to develop new ways to analyze exoplanet atmospheres and search for signs of life. This includes developing new algorithms and models to interpret the data we collect. As we continue to explore the cosmos, we are getting closer to answering one of humanity's oldest and most profound questions. Are we alone in the universe? The search for exoplanets and habitable zones is a crucial step in this quest. Ready to join the search for life beyond Earth? Learn more about exoplanet missions like TESS and the James Webb Space Telescope. Share this video with your friends and family to spread awareness about this exciting field of research. Subscribe to our channel for more updates on the latest discoveries in astronomy and astrophysics. Let's explore the universe together.